Hey everyone, welcome back to CodeMine, where we break down tech and coding topics so anyone can understand. Today we're diving into how data is actually transferred across the internet. We will cover packets, IP addresses, DNS, and I'll draw everything out to help it stick. So let's go. So firstly, what are data packets? Well, I will draw a diagram showing this is a big file, and we can break this down into smaller blocks. And this is packet 1, packet 2, packet 3, packet 4. So when you send or receive anything over the internet, whether it's an image, video, or a song, that data doesn't travel in one big chunk. It gets chopped into data packets. Each packet is like a tiny envelope. It contains a small piece of your original data. It also contains the sender's IP address and the destination IP address, plus some extra info like the protocol used and any error checking data. And packets can take different paths through the internet to reach their destination. Then your computer puts them back together like a puzzle. So they can take different paths. Well, they're broken down like this, and then they take different parts to get to your computer. Now, why use packets? And why not send the file in one go? Well, here is why we use packets. Number one, it is very efficient, as multiple devices can share the same network without slowing things down. Number two, reliability. If a packet is lost, only that part needs to be resent. Number three is flexibility. Packets can take the fastest route available. And number four, optimized bandwidth. Smaller chunks are easier to handle. Number five, scalability. More users or more data, there is no problem because packets are very scalable. Number six, the quality of service. Quality of service, important data like video calls can be prioritized. Next, we will look at IP addresses, including IPv4 and IPv6. So every device on the internet has an IP address, like its digital street address. There are two types. First type, IPv4, which is 4 numbers separated by dots, like 192.186.0.1 for example, and its max is 4.3 billion addresses. Whereas IPv6 is a newer format using hexadecimals and colons, like this could be an example. Continues on, and this supports 340 undecillion addresses. So that is way more. And you can have a static IP or a dynamic IP. A static IP is always the same, and it's good for servers. Whereas a dynamic IP changes over time. And these are great for regular users. The next part we will look at is domain name systems, also known as DNS. Do you ever wonder how your browser knows where to find google.com? That's where DNS, the domain name system, comes in. So, and then DNS comes in here, and then gives the IP address. This is a random one. So, DNS translates the domain names into IP addresses, like a phone book for the internet. How it works is you type a URL, your device asks the DNS, domain name system, resolver for the IP. If not cached, the resolver asks a root server, then a TLD server, like for .com, then the authoritative server for the domain. Step 4, the final IP address is returned. And 5, now your browser connects to that web server. Next, we will look at DNS caching. To make things faster, DNS responses are cached, saved temporarily by your browser, device, or DNS provider. This way, if you visit the same site again, you skip all the lookup steps. A tip is switching your DNS provider to Google or Cloudflare, which might speed up your internet. Now, for a real world example, here's you, DNS packets that go to different parts go to the YouTube video that you clicked on, and it makes it load. So let's recap. Files get split into packets. IP addresses help packets find the right device, and DNS translates easy to remember names into IPs. And all of this happens in seconds when you click a YouTube video, open a website, or send a meme. I hope that made internet data transfer make absolute sense. If this helped, drop a like and subscribe to CodeMind for more simple breakdowns of complex tech. I'll see you in the next one.